Assalamualaikum. I'm Asma Mushtaq from the EEVIBES, and in this tutorial, I'm going to guide you how can you create a project on the MPLAB software. So first of all, you will click on the project tab, and from here you will select the project wizard. Then you will just click on the next. From here, you have to select the particular device you want to use. Right now, I'm going to use the PIC 18F4550, so I'll just let it be. Okay, then I'll click on the next. From here you have to basically select in which programming language you want to write down your code. Right now I'm using the assembly language, so that's why I'll just select the microchipped MP assembler toolsuit. Otherwise, if I want to write in the C language, then I will have to choose C18. Okay, and from here, once you select it, there shouldn't be any kind of the cross present on these three files. Fine, then click on the next, and here you have to provide the path where you want to store your projects. Let me call it like this is my project 1. Okay, and here I have to provide the directory where I want to store it. Okay, and then you will click on the next, then next, and finish. Once you will finish it, you will see this is the output window. You need to close it, and there is the project window. In the project window, there are the different types of the files present, which is the object file, linker file, header file, source file, and some other files. Fine, you will get a simple blank page or a new file from here, and you will start writing down the code. Okay, so the first line in your code should be hash include P18F4550.inc. So this command basically will be adding all the header files that are required for the PIC microcontroller instruction set. Fine. So the next command is org00hex. So this is actually the wake up mode for the PIC microcontroller, and you must start or place your code at the starting address, because whenever the controller is powered up, the program counter actually contains this value. Fine. Now I'll just write down a simple code where I will be uh, placing a value in the reg register, and then this value will be copied into the file register at the different memory location. So move literal value to reg, which is equal to, let me just take the 60 hex value. Fine, and then move reg to file. Which file register? If I choose like 30 hex, okay, so this is basically the file register, but I have mentioned is its address, which is the 30 hex memory location. Now I'll just copy paste this command, and I'll choose different RAM locations, like if it is 30 hex, 31 hex, 32 hex, then 33 hex, or you can choose randomly like 36 hex. Fine, and I'll just end it. Okay, once you are done with that, you have always end your code with the directive end. Why? Because it actually lets the assembler know the instructions are finished over here. Fine, let's just save it. The file is saved with the extension .asm, so I will just write it as project project 1.asm. See, as I saved the file, its color is changed. Okay, now we need to add this file into the source file. So I'll just right click on it, add files, and from here I will select project1.asm and then open it. Okay, so here the file has been added. Once you have added the file, the next step is to build the target. So you will click on this. Okay, so build field. Let's just read where is the error. So basically the error is right over here. It's an illegal character. So hash include, it's not the 3 include. Okay, now build again. So build succeeded. Okay, so in this way, basically you can read the errors as well. Fine. Once you have built the target, the next step is to go to the debugger, go to the select tool, and from here you will select the MPLAB simulator, and you can see this tab actually opened. Now you will go to the view, and from here we have to view the file registers, because this is exactly where we are going to save our values. Fine. So then I will run it. You can see that the memory locations, which is the 30. So this is basically 30. Fine. Then 31, 32, because this is 2. Then 3, and then 36 hex is actually storing the value of 60 hex in the memory locations. Fine. Now let's just modify a little bit this program. Basically, I would like to now copy paste the value, which is the 60 hex, into the port B. All right. Before doing that, if I just write down this statement like move reg to file, which file register? Port B. And if I build it, we need to build every time we make any kind of the change. Okay, and then you will see build succeeded. I'll go to the special function registers because port B is the special function register, just like the reg and many other ports. And you will see there is no value copied into it. See, the space is empty, but look at the value of the lat B. Lat B is also empty. Fine. Now, why the value is not copied? Uh, let's understand that. There are basically three types of the registers associated to each port. The first one is the name of the port itself, which is the port B. Okay, these registers can be configured as the input and output port. So port B can either send or receive the data. The second one is the lat B register, which is actually the internal latch register, which holds the value of that we want to send or receive at the port B. The third register, which is associated to port B, is very important, which is the TRIS B register. This is basically known as the tri-state B register, and it helps us to configure the port either as input port or the output port. So if I send or copy 00 hex into the TRIS B, it will be configured as the output port. And if I copy 11111, which is actually FF hex, into the port B, then it will be configured as the input port. You can also remember it like 0 corresponds to O and 1 corresponds to I. Fine. So in this way, if you want to configure or send any value to port B, you just need to configure it first using the command. Let's see what command is that. So I'll just write move literal value to reg 00 hex and then move reg to file, which file register? Tris B. So this command will do what? It actually configures port B as our output port. Now, okay, let's just play it and see the values are copied or not into the port B now. So see, the port B is containing the value of 60 hex, which is equal to 96 in decimal, and also the lat B register is holding that value as well. So it is actually pre-stored in the lat B and then forwarded at the port B. Thank you for watching.